Across the globe, the need to replace and expand sewer and clean water systems presents vast opportunity. Many developed nations face aging systems long past their useful life. Stressed by population growth and sprawling expansion, costly reactive maintenance and contamination of the surrounding environment is common. In some developing countries, dense urban populations lack the sanitary sewer and clean water infrastructure vital to maintaining basic health standards. And yet, the current state of the global sewer and water systems is only a part of the challenge. A growing number of projects are required to be placed precisely on grade. With traditional installation methods, this work is often viewed to be tedious, labor-intensive, and expensive. Vermeer, a leading developer of trenchless technology, now offers a solution to help meet these widespread issues head-on. The new Axis guided boring system is a pit-launched installation method aimed to achieve pinpoint on-grade accuracy while eliminating some of the difficult steps associated with other installation techniques. A wide range of product pipe, sizing specifications, and other job site requirements can be met by the unit's versatile capabilities. The Vermeer Axis guided boring system includes a rack, drill head, rack power unit, vacuum power unit, and vacuum tank. The rack includes the thrust pullback carriage assembly and gearbox. As the thrust pullback carriage assembly moves up the rack, the gearbox simultaneously provides rotation to the cutter bit at the front of the drill head. The drill head uses a flat face cutter, and when combined with the laser guidance system, is capable of completing bores on grade. It can also be retracted mid-installation, allowing the contractor to change the cutting bit to adapt to changing ground conditions. The rack power unit contains the engine and hydraulic pumps and connects to the rack, powering thrust and pullback of the drill head and casing. As the drill head cuts its way through the soil, the cuttings are simultaneously removed by a high-power vacuum system and diverted to a vacuum tank. Let's take a closer look at how the Axis-guided boring system works together. Because of the flexibility of the major components, various setup configurations can be used to adjust the machine's footprint based on job site and transport characteristics. For instance, in an urban job site, the Axis-guided boring system can be set up in one lane of traffic for minimal disruption. Although projects greatly vary, our example consists of a 300-foot, 91-meter bore for a gravity sewer installation. First, 2 pits are dug at each end of the bore. The first will serve as the launch pit. The other will be the exit pit. The pipe laser is then set in the launch pit at the grade and depth the project requires. Next, the leveling frame is set, and then the rack assembly is lowered into the pit and positioned. The drill head is next. Contained within the drill head is a camera, which is connected to a monitor on the operator console. With the camera viewing the laser beam on the target, the operator can accurately monitor the target grade and make adjustments if the drill head moves off course. Keeping the laser dot centered within the crosshairs indicates the drill head is on course with the target grade. At the front of the drill head, the cutter bit rotates to cut through the soil. As described earlier, the cuttings are vacuumed out through the drill head and subsequent drill casing to the vacuum storage tank. Note that only the cutting bit and center drive shaft rotate. As the drill head and casing travel through the bore, the outer section remains stationary as it's pushed through the hole opened by the cutting bit. After the drill head is bored in, it is uncoupled from the carriage assembly. The carriage assembly retracts to its most rear position and is now ready for the first section of drill casing. Let's take a closer look at the drill casing. The area outlined in green is the sight channel for the pipe laser. The lower hollow section, marked in yellow, is the vacuum channel for the cuttings. At the center of the drill casing is the drive shaft, which delivers rotation to the cutting bit. Now let's turn back to the project. The first section of drill casing is coupled to the carriage assembly and to the rear portion of the drill head. Rotation and thrust from the carriage assembly resumes as the first section of drill casing is pushed through the hole. This process is repeated with numerous sections of casings until the drill head reaches the exit pit. Now it's time to install the product pipe. Based on the versatility of the Axis-guided boring system, many types of product pipe can be installed as the project requires. Depending on the job site, products such as PVC, HDPE, clay, ductile iron, or steel can be installed using one of two methods. The first method, known as pipe jacking, requires rigid constructed product pipe in segments, such as clay or steel pipe. After the drill head reaches the exit pit, the sections of drill casing are substituted for product pipe segments in the launch pit. In a similar fashion, the carriage assembly thrusts forward, pushing the product pipe segment through the bore. In the exit pit, as the drill casings are pushed through, they're hoisted out of the pit. This continues until the final drill casing reaches the exit pit and the installed product pipe now lines the bore. If the job site layout allows, it may be possible to utilize a second method for installing the product pipe, which is exclusive to the axis-guided boring system. When the drill head reaches the exit pit, it is removed and replaced with a pulling head, which attaches to the product pipe. Using the pullback method, it's also possible to attach a reamer to the end of the puller head, increasing the diameter of the bore to install product pipe larger than the pilot bore. Back in the launch pit, the carriage assembly retracts, pulling the drill casing and product pipe back through the bore. When the carriage reaches its fully retracted position, the drill casing is uncoupled and hoisted out of the launch pit. The carriage returns to its most forward position, couples with the next section of drill casing, and repeats the process, pulling towards the launch pit until all drill casing has been removed and product pipe now lines the bore. You have now seen the basics of how the Vermeer Axis guided boring system works. A simplistic design, pinpoint accuracy, and an environmentally friendly approach make the Axis system a viable alternative to current water and sewer installation methods. To learn more about the Axis system, contact your local Vermeer dealer today.